something, different today, but not that different from last class. At lunch, one of your friends has a happy face, and one of them has a sad face. All right? The happy face friend received a 60% on her bio test. I know, but why are you happy? And the sad friend received a 60% on her history test. 60% doesn't sound very good, right?
All have different attitudes about school.
Sure, that could be true. But how could they both receive the same score, have different reactions besides that?
What else? That class that you grade on a bell curve.
Yeah, maybe graded on the curve. Wasn't really paying attention.
I mean, parents can get on there.
Right? Like so many different reasons. But two same scores, different subjects. Well, how about this? If I told you that the mean or the average of the biology test was a 50%, okay? And the average or the mean of the history test was a 70%. Does that make you think, oh, okay, I get it?
Yeah. One's above average and one's below average.
Yeah. Bio test, if the class average is a 50, then if you score 60, how did you do in terms of the class average?
You did 10 points ahead.
You did. You did 10 points better. But for the history test, if their average is a 70, then how did you do with your score 60?
10 points over.
Yeah, right? So, okay, that gives us kind of an insight into why one is happy face, one is frowny face.
You would find out with AP classes.
Yeah, yep. I'm sure AP classes kind of curved a little bit. So another statistical measure that we're going to use is called z-scores. Okay? It basically, it makes a data point, right? It helps you to compare the data point in terms of the average, okay? And sometimes when we analyze our data, right, we have to take scores from different things. Like they're not all the same, so we can't just compare it just by looking at it, okay? If we want to compare different information and make them have the same, make them like at the same level, right? Then we have to use z-scores. So here's the formula for the z-score. Z equals x, which is your score, the data point, minus the mu, the mean, divided by sigma, divided by standard deviation, okay? This is on your formula sheet. You do not have to memorize this. So, for the biology test, the mean is a 50 and the standard deviation is 10. Let's find the z-score for happy face. Remember, z equals x minus mu over sigma. Right?
Yeah.
My X is a little weird there, sorry. So for the bio test, z-score, what did they score in the bio test?
The average is...
No, not the average. What did they score? The 60. So 60 minus the average, which is 50, divided by standard deviation, 10. So when you put this in the calculator, put everything in the numerator first, then hit enter, and then do divided by 10. So do 60 minus 50, enter, divided by 10. 1. Alright, so this one has happy face, z-score 1. Now, history test, sad face. Let's find this person's z-score. So this person also scored a 60. But the mean for the history test is what?
70.
70, so minus 70. Divided by standard deviation is also 10. So what is the z-score? Perfect.
So she was 1 point below the average and the other one was 1 point above the average.
Yeah, but now you have these z-scores, right? A positive z-score, guys. Oh, it's down at the bottom. This is down the bottom of your page. A positive z-score, like the positive one for happy face, it means that it is above the mean. A negative z-score,
It's below.
yeah, it means that the data point is below the mean. And guys, the bigger the z-score, the further away the data point is from the mean. But the bigger the z-score, like that's what you want. Okay? It means it's better. Alright? So let's look at the next page. We're going to take z-scores, just the z-scores and just the z-score formula. Okay? Given the following information, we're going to find the missing value. We're basically going to set up the equation. Let's round it to 2 decimal places. So remember, the formula for z-score is z equals x minus mu over sigma. Yes? Number 1. Okay, let's see. What am I trying to find? Gotta find z, right? Let's plug in everything. Z equals x minus mu over sigma. Now plug all of that in and tell me what you get. 2 point what?
25.
All right. Z equals 2.25. Good. It's nice when we're looking for the z, right? You just have to plug it into the formula and just go, right? Number 2, though, they want you to find x. All right, let's plug this in.
You multiply 4.
Yeah. So let's see. Z equals, negative 2.5 equals x minus the mu over 4. And 2 is right. In order to solve for that x, you have to multiply the 4. That gets rid of these guys. You have x minus 21 equals, what's 4 times negative 2.5?
You get 10.
All right, negative 10. And then what?
Then you will add 21.
Super. Add 21. And then x equals?
Negative 31.
Negative 10 plus 21. Good. So your x equals 11. Any questions about that? All right. So you can also use z-scores to compare 2 sets of data. All right. And this is when you would normally, this is the most commonly used way. Basically, for the 2 different situations, you got to find the z-scores. Okay. Find the z-score for each situation. And then whichever z-score is higher or bigger, that's the better situation compared to the rest of it. Does that make sense? Bigger the number, that's the winner. All right, so this leads us right on over to our word problems here. Oh my goodness. All right. So, the first one. It's a lot of stuff here, but just pick out the information that is useful to you. It says the children of the Smith family were arguing at dinner as to who did better on their test at school. So Sally earned a 90% on their spelling test, okay? But the average grade on the spelling test was an 82, and the standard deviation was 4, right? So I'm going to write that, well, actually, no, I can just highlight. So the other Smith child is John. John earned an 85% on his algebra test. It's not a 90 like his sisters, right? But they're different subjects. Do you agree? Okay. The average grade on his algebra test was a 70 and the standard deviation was 5. So who's right? Who did better on their test? How many situations do you have here?
4.
2. Because you have Sally's grade and you have John's grade. So, Sally has a score of what? 90. Mu is 82. Standard deviation is 4. Right? Let's find her z-score. Z equals her 90 minus the 82 divided by 4. Do you agree? What is Sally's z-score? 2. So Sally has a z-score of 2. Now, time for John. John's score is what? 85.
Minus 70 divided by 5.
Mu is 70. Standard deviation is 5.
And that's 3.
Is it 3?
So then Sally did better because she's closer.
No.
No, John did better because he's farther away from the average.
No, so, okay. Hold on. Right? Is Tom right? Is John's z-score 3?
Yeah.
Alright, so don't even complicate it like that, okay? Who has the bigger z-score? John. John wins. Okay? He did better because he is 3, right? Above the mean. Do you know what I'm saying? They're both above the mean, so they both did well. But John did better because he's at 3, not at 2. Yeah? It's higher. Okay, so the winner here, John. Alright? So look at the next one. And mind you, this was written probably about 2-3 years ago, okay? Who is better at their sport as compared to the competition? So we have LeBron James, who scores 27.1 points per game when the league average is 9.63 points per game and the standard deviation is 5.6. Again, not recent, right? Because I'm sure those averages have gone up.
Yeah, he's like 30 points.
I'm sure, because he's an animal.
Yeah.
So we have LeBron James. And then we have Peyton Manning, who passes 342.3 yards per game when the league average is 235.6. And the standard deviation is 35.3. Who is better at their sport? LeBron James or Peyton Manning at this time, right?
LeBron James is a basketball player, but who's team?
So you guys are just telling me because of your own bias, right?
I mean, he has the points and the numbers though.
You know what? Find their z-score. The only way you can accurately compare 2 different sets, right? 2 different situations is to find the z-score. See who has the higher z-score. Let's do this. So for LeBron James, his z-score is 3.11. Peyton Manning, 3.02.
Told you guys, right?
Yep, you were right. LeBron James. But he didn't do better by that much.
Yeah.
Yes. So, I get it. LeBron James is a very good athlete. But when we look at their stats here and we get their z-scores, then we can compare. It's apples to apples now. You know what I'm saying? We're talking about the same thing. Okay? Any questions about this? Alright, I got all fired up because I don't, you know what I mean? I just feel like the NBA now is just such a debacle. All right, so now we're going to talk about using z-scores to find the probabilities and the percentage. So basically, guys, the z-score tells you the distance from the mean, right? But it can also tell you the probability. All right, and that stays as a decimal. And the percentage. Remember, you're timesing it by 100 to get the percentage, right? All right, here's how you get the probability from a z-score. You use the table, okay? The table is used to tell you what percentage of the data is to the left of the z-score, okay? Below that z-score. The table always tells you below, all right? You want to round your z-scores to 2 decimal places in order to get these values from the table. I'll give you a copy of it. Please don't lose it. All right, so given the z-score of negative 1.25. So if you're given the z-score of negative 1.25, negative 1.25, here's what you need to do, okay? What is your question? I haven't started yet. What? Yeah. All of these that I'm giving you, you're going to get on the SOL, okay? So you see these first 2 numbers, guys? Those are the numbers that are going to be on the left side here. Okay? If you look at your table, you have a negative number side. And if you look at the back, you have a positive number side. You see that? So this one is a negative 1. So you're going to be on the negative side, okay? So we're going to go to negative 1.2 on the left here. All right, so let's see. Negative 1.2, you see that right there? Yeah? What is the second number after the 2? What was it? Negative 1.25, right? What was the example? Negative 1.25, yeah? So, pay attention, stay with me. Negative 1.2. These columns tell you the second number. You see how it's 0.00? So this one is negative 1.20. That's not what we want. Negative 1.21. Negative 1.22. Negative 1.23. Negative 1.24. And negative 1.25.
It's just like how you meet what do you call it? A multiplication chart table?
Yeah, I guess so. Yeah, kind of like that. All right, so then you're probably, because look, negative 1.25. You see that? So it's 0.1056. That is your probability. 0.1056. Okay, this is your probability. If you wanted the percent, all you have to do is just move your decimal point 2 places to the right to give you 10.56%. Okay? We're going to try some more. All right? It says find the percentage of the data that falls below. All right, guys, below and the percent. Okay. Remember, this is exactly just what's in your table if it's below, right? So if you have a z-score of negative 2.89, all right, go and find negative 2.8, and then you're going to go over to the right until you get to the 9 column. So negative 2.89. Negative 2.8 right here, right? And then where's the 9? Well, this is 0, so just count from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you agree? Right there. Does everyone see that? If you don't see it, say something. Are you okay? All right, so 0.0019. 0019. This is the probability. Then the percent is what? Which is 1, 2. So 0.19%. No, 0.19%. Okay? No, because you say 0.19.
I did this for science or chemistry.
Yeah, and you guys did like sig figs.
Yeah.
So let's try number 2. Go to 3.21. Okay, so you're going to go to 3.2. Oh, now it's a positive. So go to the back. Go to your positive side. 3.21. Let's see. 3.2. Oh, no. Gotta scroll down more.
It sounds like radio stations.
0, 1, 2. 0.9994. Yeah?
I bet you move over one spot.
No, because it's 3.21. Right? But look at your first column. Your first column 0.
Yeah. Oh, okay.
All right, look, you're going to use this. The first column 0. So when there's 3.2, you see how that one's 0?
Yeah.
So 0, 1, 2. What's that one? 0.9994. Okay?
Yeah.
Probability is 0.9994. So guys, what is the percent?
99.94%.
Good. 99.94%. That means 99.94% of the data falls below that z-score.
Looks like the 99.9% of drones should show if you use this answer times
So we just found below. Below is what is on the table. Now, you can find the probability of falling above. Okay? So if the total area under the curve is 1 or 100%, and what the table gives you is 0, what you basically have to do is you have to do 1 minus the probability. You have to subtract it from 1. Okay? So let's find the z-score. It says find the probability of falling above. Let's find the z-score for this guy. Negative 0.04. Whoa, guys, be careful. This is negative 0.04, right? So you're going to look for negative 0.0 and then go to 4.
negative 4%.
Let me see. Oh, there we go. Negative 0.0, right? And then 0, 1, 2, 3, 4. 0.5160. Oh, no. That was positive. Sorry. Negative. There we go. 0, 1, 2, 3, 4. What is it?
4840.
0.4840. So probability is 0.4840.
48, 40.
No, you're not doing percentage, it's just a probability. But since they want above, you have to do 1 minus that. What is 1 minus 0.4840?
Oh, negative 4839.
Huh? 1 minus?
Yeah. Oh, I didn't put the point.
0.516.
0.516. I'm leaving it like that. I'm not turning it into a percentage because they just said give me the probability, right?
That's not funny.
All right, so let's look at the next one. The z-score of, so the find the probability of falling above the z-score of 2.1. Oh, that's 2.10, right? So let's go to 2.1. 2.1 here, 0, which is 0.9821, right? But since since it said above, what do you have to do? Yeah, subtract it from 1. So 1 minus 0.9821 gives me what?
So it's 0.01. It's 0.0179.
Good. And that's it with those. Think about what you just did. You just found the probability of falling below a z-score, probability of falling above. Now, we're going to talk about the probability of falling between two z-scores.
So you have to do the top, the above and below and the top, so you get to the.
Well, you know what? So now, I mean, it says right here, use the table, find the probability for both of the z-scores, and then just do a bigger number minus a smaller number. That's it. That gives you the between. Yeah? Is anyone still having trouble reading the probabilities from the table? Okay, then let's do this. All right, find the z-score for negative 1 point, then find the probability, sorry, for negative 1.32, and find the probability for a z-score 2.43. Let's find both of those from the table, one at a time. Did you guys get both of these probabilities? So now, just take the bigger number, subtract the smaller number. 0.9925 minus 0.0934. And they said find the probability, so I don't need to change it to percent. What did you get? Point. Super. Thank you, Ethan. Now let's do the next one. All right, thank you, Cindy. She did number 6 for us. Each of the probabilities, and then you do big minus small, and you should have 0.6635. Yes? Great. Any questions? All right, so some real life examples. Okay. If you scored an 89% on our last test with a mean of 84 and a standard deviation of 4%, what percentage, oh, keyword here, percentage of students scored what? Higher than you.
Move the decimal place from like.
Okay, so you got to move the decimal place because it's a percentage, but what does higher mean? Below, above, or between? Ah, so you're gonna have to do that something to the probability, right? So first off, let's find the z-score. Z equals x, what we got on the test, 89 minus our mean divided by the standard deviation. What does the z-score equal? 1.25. So what is the probability here? Means go to your table for 1.25. What do you get?
44.
What?
0.8944.
Oh, is it 0.8944? Yeah, all right. So 0.8944, but it said above. So what do you need to do for above, guys? Leave it? This is below. Kevin, what do we do for above? Subtract it from what? Good. Gotta subtract it from 1 to get the above. Good. So then what is it? What percentage of students scored higher than an 89%? Was 1 minus 0.8944. 0.1036? 56. But I want the percent, so
Move the decimal place.
okay, so then that equals 10.56%. So almost 11% of the students scored higher than an 89%. So this 89 is pretty good, right? Yeah. All right, look at number 2. Books in the library are found to have an average length of 350 pages. Okay, so mu equals 350. With a standard deviation of 100, what percentage, okay, so move your decimal point, right, of the books are what? What percentage of the books are? Between. Oh, okay, keyword, between 200 and 400 pages long. All right, so we have 2. X equals 200. And then we have an x equals 400. Guys, find the z-score for both of them. Find the probability. And then give me the probability, the percentage between. So, z-score for 200 pages is what?
Is 1.5, negative 1.5.
Negative 1.5. The z-score for 400
is 3.964.
Didn't you get 0.5?
Yeah.
Yeah, did you get 0.5? 0.5, right?
Oh, yeah.
Now, find the probability for each of these. What's the probability for negative 1.5? Ooh, negative 1.5, 0. 0.668? 0.0668? What's the probability for 0.50?
0.6915.
0.6915. And then what do you do to find between, guys?
Subtract.
Subtract. Big minus small. And then what do you get? 0.6247. Right, that is, oh no, percentage. Excuse me. 62.47%. Oh my. Alright, and if you guys remember to do the percentage, great. But I'm not going to count off if you forget. But if you do remember, it's great. Alright? How do you guys feel about this? Is this good? It's easy? Alright. So, let's see. Alright, look at number 1. Let's do this, okay?
Oh, I remember they actually did number 6 when I was in elementary.
Oh, good. A national achievement test is administered annually to 7th graders. The test has a mean score of 120. So mu equals 120. Standard deviation of 12. If Meredith's z-score equals 1.25, what was her actual score on the test? This has nothing to do with the table. It's just to plug it into your z-score equation and solve for x, right? So this would be 1.25 equals x over 12. Solve for x, okay? All right, and then add 120. So what is her score?
It's 135.
135 is Meredith's score. All right. You guys did a really great